Hello everyone, welcome to Testbot MBA Prep. In this session, we will look into Surds, Indices and Logarithms. It's a complete class. We'll first look into the exponents and Surds and then we will look into logarithms. I advise all of you to not to skip this video and watch the entire concepts as we solve 23 more than 23 problems in this session, this complete session. All are cat and zat level. Alright, so we will also cover the previous year cat, previous year zat problems. Each and every concept will be covered, nothing will be missed, so do watch it till the end. Now, what do we mean by exponent or index? It's a basic term. Let us take 10 square. So if we consider 10 square, here 2 is the exponent. Exponent, it is also known as index, right? And 10 is the base. Let us look into some law of indices, some laws. The first one is x power 0 is equal to 1. Any variable to the power 0 will be equal to 1. And what is meant by x power 1? This is equal to x. And the third law is x to the power minus 1, which is equal to 1 by x. The fourth one is x power m into x power n. Two different parts but the same base, right? Same base. This is equal to x power m plus n. All these are basic laws, but we can solve any problem related to indices using these laws. And what is x power m by x power n? This is equal to x power m minus n. The sixth one is x power n whole power n. This is equal to x power m into n, and x into y, xy to the power n. This is equal to x power n into y power n, and x by y whole power n is equal to, we can write it as x power n by y power n. We can divide that, and x power minus n, this is equal to 1 by x power n. We can write it as 1 by x power n. So these 9 are sufficient to solve any problem related to indices. I hope everyone already mastered these basic laws. Let's move on to radical and surds. What is meant by radical? Radical is also known as surd. So anything which is in the form nth power. So anything in the form which is like this. How can we read this? Nth root of x, or we can also read it as x radical n, right? X radical n. So this is n is the index. This is known as vinculum, right? This one is known as vinculum. And what is x? X is radicand. Now no one asks you what is meant by vinculum, what is meant by radicand and all that. Just to make you understand, I am just briefing all this. Now if we say 2 power 5 by 2, right? If we take this, we can express this as second root of 2 power 5, right? Second root of 2 power 5. Now we can modify this as second root of 2 whole power 5. We can let this 5 out of this and we can make it as second root of 2 whole power 5. Hope you got this. And what is meant by principal square root? Most of you get confused the difference between square root and principal square root. Let us say square root of 4, right? What is square root of 4? Square root of 4 is plus 2. It can be plus 2 or it can also be minus 2. But what if I say the square root of 4? Now the square root refers only to plus 2 and the square root doesn't include minus 2. Please remember this. So this is the principal square root, right? If generally square root, if in any question, generally if square root is mentioned without the, then you can take it as plus 2 or minus 2, plus and both of plus and minus of the number, right? The root. Whereas if the is mentioned, the principal must be taken in this case 2. So principal in this case, principal means the positive root, right? So that's the difference between the square root, that which means the principal square root, and just square root. Hope you got it. Let us take a power b and a power c. Now can I say that b is equal to c? Yes, I can, because here the bases are equal. If you observe the bases are equal. When bases are equal, we can equate the exponents, right? So in this case b is equal to c. So for instance 5 power 3x, this is equal to 25y. Now we cannot equate 3x is equal to y because the bases are not equal. Here it is 5, here it is 25. So let us make this 25 as to the base of 5. So how can we write 25 as 5 square? So 5 power 2 into y. Now we can equate 3x is equal to 2y. So that just a simple application. Okay. So arrange the following in ascending order. Now if we observe all the bases are not equal, then we cannot equate the exponents. Now we shall do one thing, we shall make all the bases equal so that we can equate the exponents and we can derive the value. So how can we make it? So how can we write 4? 4 can be written as 2 square. So 2 square whole power 12. 16 can be written as 2 power 4 whole power 7, and 128 can be written as 2 power 7 to the power 2, and 32 can be written as 2 power 5 to the power 5. Now just multiply this. 2 power 2 into 12, this is 24. This is 7 into 4, this is 28. This is 14, and this is 25. Now look here, the bases are equal. All are to the base 2. Now just compare the exponents. So what do we want ascending order? So it's 14, 2 power 14 comes first, and then 2 power 24 comes next, and then 2 power 25 and 2 power 28. So the order is C, A, D and B, right? So let us solve this. If 9 power 2x minus 1 minus 81 to the power x minus 1 is equal to 1944, then find the value of x. This appeared in CAT 2017 slot 1. So it's a simple problem. Here just observe the bases. Here it is 9, here 81. So we can make 81 as 9. We can represent 81 as a base of 9. So how can we do it? How can we do that? Here 9 to the power 2x minus 1. 81 can be written as 9 square. So 9 square into x minus 1, this is equal to 1944. So 9 to the power 2x minus 1 and 9 to the power 2x minus 2, this is equal to 1944. Here just observe, here we have minus 2 and here we have minus 1. Oh, sorry, I didn't mark minus here. Okay. So here we have minus 1 and here we have minus 2. Now tell me one thing. Can we equate the exponents here? 2x minus 1, 2x minus 2. The bases are equal, right? So can we equate them? No, we cannot do that, because if there is a multiplication sign between these two, then we can do that if the bases are equal. Here we have minus, so we cannot do that. Even it is plus, we cannot do that. For only multiplication, for only product, we can equate the exponents if the bases are equal. So what shall we do now? Now we shall make this power 2x minus 1 as 2x minus 2. How can we do that? 9 to the power 2x minus 2 into 9 minus 9 to the power 2x minus 2, this is equal to 1944. Now this is as same as this expression, because here 9 to the power 2x minus 2 into 9, this refers to a power m into a power n, which means 9 to the power 2x minus 2 minus 1, and again this is equal to 9 to the power 2x minus 1. Hope you got this. Now we can take 9 to the power 2x minus 2 as common, so that we have 9 minus 1, this is equal to 1944, and 9 minus 1 is equal to 8. If we move 8, if we bring 8 to this side, we'll have a 9 to the power 2x minus 2. This is equal to 1944 by 8. So 1944 by 8, this is equal to 243. You can use your calculator, guys, because it appeared in CAD, and CAD does give you calculator. So how can we do this? 9 power 2x minus 2, this is equal to 243. 243 can be written as 3 power 5. So why we are making 243 into 3 power 5? We can also convert 9 as 3 square, so that the bases will be equal. 3 square into 2x minus 2, this will be equal to 3 power 5. As the bases are equal, we can equate the exponents. So 2 into 2x minus 2, this is equal to 5. 4x minus 4, this is equal to 5. X is equal to 9 by 4. So option 2 is the answer. So please remember the basic laws, basic properties. Those are sufficient, more than sufficient to solve any problem, be it Z, be it CAT, or anything, IIFT, SNAP. Those are enough. Let us solve this. If 9 to the power x minus 1 by 2 minus 2 to the power 2x minus 2 is equal to something, then find x. This appeared in 2017 CAT slot 2. Alright. So be it CAT or be it Z, the properties, the basic rules remain same. Please remember them. So if you observe, 9 can be written as, we can make 9 as to the base 3, and here on the right hand side also we have 3. On the left hand side we have 2 base 2, so that on right hand side we can make 4 as to the base 2. Fine. So 9 can be written as 3 square into x minus 1 by 2 minus 2 into 2x minus 2 power 2x minus 2. This is equal to 4 can be written as 2 square whole power x minus 3 into 3 to the power 2x minus 3. So just multiply this. 3 power 2x minus 1 minus 2 power 2x minus 2. This will be equal to 2 power 2x minus 3 power 2x minus 3. Right. So let us bring the equal bases to one side. 3 power 2x minus 1 plus 3 power 2x minus 2, this is equal to 2 power 2x plus 2 power 2x minus 2. Again, this resembles the previous problem because bases are same, but we cannot equate the exponents. Why? The sign is positive. In the previous case it was negative, but now it is positive. Anyways, we cannot equate the exponents. But what can we do is we can make the exponents equal. How can we make it? We can make, so here we have 2x minus 3. We shall make 2x minus 1 in terms of 2x minus 3 as 3 power 2x minus 3 into 3 square plus 3 to the power 2x minus 3. In the right hand side we will do the same thing. We will make 2x as 2x minus 2, 2x minus 2 into 2 square plus 2 power 2x minus 2. Fine. So we can take common 3 power 2x minus 3 as common. So here we have 3 square can be written as 9 plus 1. This is equal to 2 power 2x minus 2. We are taking this common. So 2 square is 4 plus 1. So let me write it here. So if we observe 9 plus 1, this is 10, and 4 plus 1, this is 5. So here this will be 1 and this will be 2. So we can rewrite it as 3 power 2x minus 3 into 2. This will be equal to 2 power 2x minus 2. Right? So here we have base 2. On the right hand side also we have base 2. On the left hand side we have base 3, but on the right hand side we did not have any base 3. So that we are making this one as 3 power 0. Right? So that the bases are equal in both the sides. Right? Equal on both the sides. So now 2x minus 3, this will be equal to 0. We are equating third base, right? Which is this base with 3 and 3. We are equating these two. So 2x minus 3, this will be equal to 0, and x will be equal to 3 by 2. This is our answer. Alright, so if m and n are integers such that, so this expression is given, then m is, okay, we are asked to find out the value of m. So this appeared in CAT 2019 slot 1. Okay, so if we observe this, we can make root 2 as the base of 2, 3 you can make it base of 3, 4 in terms of 2, 9 in terms of 3, 8 in terms of 2, 3 as it is, 16 we can make it to the base 2, and 64 also we can make it as base 2. Alright, let us take this 2 root 2 whole power 19, we can write it as 2, root 2 can be written as 2 power 1 by 2, so 2 power 1 by 2 into 19, this is equal to 2 power 19 by 2, and 3 power 4, 4 square can be written as 2 power 4, 9 power m, it is written as 3 point as the base of 3, so 3 power 2m, so 8 power n can be written as 2 power 3n, so this is equal to, this is 3 power n, 16 power n, m can be written as 2 power 4m. So fourth root of 64, this is 60 root of 64, so this is 64 to the power 1 by 4. Now 64 is 2 power 6, so this is 2 power 6 by 4. Now the bases are equal, right? So 2, 2 and 2, here we have 3, 3, 3, 2, 2. Now the bases are equal, we can use the formula a power m into a power n. So 2 power, what is 19 by 2? 19 by 2 is 9.5 plus 4 plus 3n. Now base of 3. So 3 power 4 plus, this is 2m. This is equal to, on the other side we have 3 power n. There is no other base of 3. So we will move on to 2 power 4m plus 6 by 4 can be written as 1.5. Now see here, just observe, the bases are equal. Here we have 2, here we have 2, here 3, on the other hand we also have 3. If we equate the exponents of base 3, what do we get? We get 4 plus 2m, this is equal to n. Right, if we equate the bases of 3, we will get 4 plus 2m is equal to n. Let us equate 2 now. 9.5 plus 4 plus 3n, this is equal to 4m plus 1.5. Now 12 plus 3n, this is equal to 4m. 12 plus, what is n? n is 4 plus 2m. So 3 into 4 plus 2m, this is equal to 4m. So let me write it here. So now this is equal to 24 plus 2m, this is equal to 0. See, I am calculating all this because I won't leave anyone. No one should feel uncomfortable while this entire calculation is going on. So 2m is equal to minus 24 and m is equal to minus 12. M is equal to minus 12. So what is the answer? Answer is option B. Okay, so let us solve this. If 5 power x minus 3 power y is equal to something, and 5 power x minus 1 plus 3 power y minus 1 is some value, then find the value of x plus y. This appeared in CAT 2019 slot 2 and is a theta question. Alright. You can start solving by taking either this one, or you can also solve by taking this one. But I will take only this value, because 5x minus 3y is equal to 13438, because we have an upper bound in this case, because we have minus here, which means the value that is on the right hand side shouldn't be greater than 5 power x. It will definitely be less than 5 power x. So 5 power x must definitely be a 5-digit number. How can you find out the 5-digit number? Let's see, 5 power 4, what is 5 power 4? It is 625. We have to make this a 5-digit number. So 625, if this 3-digit number can be, if it is multiplied with a 2-digit number, which is 5 square. Now, at this point of time, please remember this simple funda. This will definitely be helpful while solving some of the questions. If you are multiplying a m digit number with a n digit number, right, with a n digit number, then either you will get m plus n digit number or you will get m plus n minus 1 digit number. For instance, here we are multiplying a 3 digit number and a 2 digit number. So either we will get 3 plus 2, a 5 digit number, or we will get 5 minus 1, which is 4 digit number. Since I already know this, I'm just multiplying 625 with 25 so that we can get a 5 digit number in this case. Alright, and this rule applies everywhere. You take some value of m, you take some value of n, right, any digit number, multiply, either you'll get this or you'll get this. So what is 625 into 25? Just use your calculator. This is 15625. So 5 power x, we shall assume 5 power x as 15625. Let us bring this value to the other side, minus 13438. This will be equal to 3 power y. Now just subtract this, we'll get 2187. This is equal to 3 power y. Just split this value to 2187. Just split this. One hint here is, on the other side we have base 3. So you have to split in such a way that you have to get the value in terms of base 3, right? So 2187 can be written as 81 into 27. 81 can be written as 3 power 4. 27 can be written as 3 cube. Now 3 power 4 into 3 cube, this is equal to 3 power 7. This is equal to 3 power y. As the bases are equal, just equate the exponents. Y is equal to 7. We know the value of y, just calculate the value of x. What is x? If you observe here, we substitute this value for 5 power x. What is this? This is equal to, this value is equal to 5 power 6. Now 5 power 6 is equal to 5 power x. So x is equal to 6. Here we ask the addition, the value of x plus y. X is 6, y is 7. So 6 plus 7, this is equal to 13. See, theta questions in CAT most probably be easier than remaining questions. This doesn't mean remaining questions will be too difficult. You may find theta questions to be difficult because we do not have options. Otherwise, these are relatively easier than this. Of course, one or two theta questions may be extremely difficult. You can leave them, simply ignore them. But the positive aspect is, as you know, theta questions have no negative marking, so that it's like a bonus. If you get it right, it's like a bonus. And each and every mark, each and every question getting right has a huge impact on your percentile, drastic impact. So just look at the problem. If you think you can, just solve it with 100% accuracy, and it's worth it. Worth spending on theta questions, right? So let's move on to the next one. So square root of a surd. If I say find the square root of 17 plus 12th root of 2. So if I ask you to find out the value of the square root of this surd, right, which is 17 plus 12 root 2, what do? Just square it. So if we replace this with root a plus root b, right, root a plus root b, where root a is 17, root b is 12 root 2, and if we square this, what do we get? We get a plus b plus 2 root ab. Just simplify this, ultimately we'll get this one. Now a plus b is equal to 17, 2 root b is equal to 12 root 2. Now what are the options given? Here the options are root 3 plus root 6. The second one is 4 plus root 8, 3 plus root 8, and the last one is root 5 plus root 3. Now just check now. 3 can be written as root 9 plus root 8 is as usual. Okay. So a plus b equal to 17. Now we can simply say that here 9 plus 8 is equal to 17. Right? 9 plus 8 is equal to 17. Hence option 3 is answer. Okay, let us take second option. 4 can be written as root 16 plus root 8. Right? Now 16 plus 8 is not equal to 17. So this is not answer, this is not answer, this is not the answer. Option 3 is the answer. Simply take the square root and just compare, you will get this. Obviously this is not a cat level question. You can expect this in CMAT, Tissnet, in such kind of questions. Obviously they will just ask you to compare or to arrange them in the ascending order or the descending order. So this is how you find the square roots of any surd. Now how do we compare surds? Let us take an example. So we have two surds here. This is the first one, this is the second one. Which one is greater between these two? The same thing, just square them. How to square them? Root 5 plus root 23 whole square and root 3 plus root 29 whole square. Alright. Now this will be equal to 5 plus 23 plus 2 root 115, and this will be equal to 3 plus 29 plus 2 root 87. So this is 28 plus 2 root 115. This is 32 plus 2 root 87. Now what is 115? 115 lies between 10 square and 11 square, right? 10 square and 11 square. So we can say that 28 plus 2 into this lies between 10 square and 11 square, and on the other side 32 plus 2 87 is in between 9 square and 10 square. So 2 into 9 square and 10 square, 87 lies between somewhere here. So 28 plus, so x will be equal to 2 into 10, 20, and 2 into 11, this is 22. X lies in between 20 and 22. On the other hand, we have x lies between 2 into 9, 18. Y lies between 18 and 20. Just sum up this. 28 plus 20, this is 48, and this 28 plus 22, this is 50. This is 50 and 52. See this, x lies between 48 and 50. Here y is between 50 and 52. So definitely this value is greater than this. Hence root 3 plus root 29 is greater than this surd. This is how you compare two surds. Now you may ask me, so here we have x which is very clear, which is between 48 and 50, and here y is in between 50 and 50. There is no overlap. There is no overlap. What happens if there is an overlap? Overlap means, see, let us say x is between 48 and 50, y is in between 49 and 53. Now x can be 49.5 here, y can also be 49.5 here. We do not know the value. In this case we cannot compare. So how to tackle if this overlapping arises? Just do one thing, take the approximate square root. How can we calculate the approximate square root? Let me write it here. Approximate square root. See, here we have 87, square root of 87. 87 lies between 81 and 100, which is 9 square and 10 square. Now what you have to do is, what is 81? 81 is 9 square. So 9 plus, what's the difference? 87 and 81. What's the difference between these two? 6 by 2 is common. 2 is standard. So while calculating approximate square root, the denominator 2 is always common for calculating any square root. So 2 is fixed, plus just bring this 9 here. This is how you calculate. Now this is equal to 9 plus 6 by 11. 6 by 11 is equal to 0.33. So this is equal to 9.33 approximately. Now I am using the calculator to find out the actual value of root 87. So the actual value according to the calculator is 9.327. This is what I got, 9.327, but according to this technique we got 9.33, which is very close. Obviously if you have calculator, who will do all this? You won't do this if you have a calculator like CAT. I'm just emphasizing about non-CAT exams like SNAP, IFT and such exams. So there you won't get calculator. You have to use this technique. Definitely comes handy in those exams, right? Now, which of the following is greater, fourth root of 5 or third root of 4? How can we do this? See, fourth root of 5 and third root of 4. Fourth root of 5 can be written as 5 to the power 1 by 4, and third root of 4 can be written as 4 to the power 1 by 3. Awesome. Can we equate the bases now? Now we cannot equate. There is no possibility to equate the bases. The only thing we can do is to equate the exponents. How can we equate the exponents? We shall multiply 1 by 4 with 3. The denominator numerator with 3. And we shall multiply this 1 by 3 with 4. Alright. Now what do we get? 5 power 3 by 12. Now this is 4 power 4 by 12. Now this can be written as 5 power 5 cube whole by 12, and this is 4 power 4 whole to the power 1 by 2. So 4 to the power 4 whole to the power 1 by 2. What is 5 cube? 5 cube is 125. What is 4 to the power 4? This is 256. As the powers are equal, just we are comparing the bases. So which one is greater? This is greater. Hence, third root of 4 is greater than fourth root of 5. See, whatever question we are taking, these all are related to CAT, XAT, SNAP and MAT. So these are also useful for CMAT and Tissnet as well. So don't leave any question which is being discussed in this video. Listen to all the concepts, solve all the problems. After this you can practice level 1 questions and level 2 questions of any standard book like Quantum CAT, and don't solve more than 40 questions because the time is very limited, and don't delve into each and every topic at this point of time. Just solve 40 questions. 40 is a good number as of now. Besides these videos you can solve them. Alright, find the largest. Here what is given? 2 power 1 by 2, 3 power 1 by 3, 4 power 1 by 4, 6 power 1 by 6, 12 power 1 by 12. This appeared in CAT 2006. Alright, so 2 power 1 by 2 we shall make, there is no way to make the bases equal. The only way is to make the exponents equal. How can we make the exponents equal? Just multiply 1 by 2 with 6. Numerator and denominator with 6. This one with 4. This one with 3. This one with 2. This one with 1. So that everything will be in the power of 12. So 2 power 6 by 12. 3 power 4 by 12. 4 power 3 by 12. And this is 6 power 2 by 12. And this is 12 power 1 by 12. Alright. Now how can we do this? 2 power 6 whole power 1 by 12, 3 power 4 whole power 1 by 12, 4 cube to the power 12 and 6 square to the power 12, 12 to the power 1 by 12. So 2 power 6 to the power 1 by 12. 2 power 6, what is 2 power 6? 2 power 6 is 64, 3 power 4 is 81, 4 cube is 64, 6 square is 36 and 12 is 12. The exponents are equal. So we are comparing the bases, right? We are comparing the bases. Which one is greatest? 81 is greatest. Hence 3 power 1 by 3 is the largest. Alright, so we looked into all the concepts of surds and indices. Now we shall look into logarithms. You can generally expect one question definitely from logarithms and one question from surds and indices that you can expect. So two questions in this cat new pattern you can definitely expect. And if snap, nmat, tissnet, cmat are concerned, this is important. Not so much for tis, but for snap this is important, for nmat, for cmat as well. For tis you have to study, you must have some idea on this, at least the basic problems that we are discussing in this video. We are also discussing advanced level problems in this video along with the basic concepts. So at least try to understand this, that is enough as far as Tissnet and other non-CAT exams are concerned. For CAT, this is a must. For ZAT, this is a must. Besides this, you can practice level 2 of quantum CAT. Alright. So let us look into some properties of logarithms. We all know the properties. So log of a into c, right? Log of a into c to the base b, this is equal to log a to the base b. As it is multiplication, we have addition, plus log of c to the base b. So what is a logarithm first? What is a logarithm? What is the purpose of logarithm? Just tell me, what is the purpose of logarithm? See, if we take a power x is equal to n, some constant, right? We can express a in terms of n. We can express n in terms of a. Like a is equal to n power 1 by x. We can express like this. But can we express x in terms of something which is a power? X is a power in this case. X is equal to something. No, we cannot do that. That's where the logarithm concept was introduced, right? So how can we apply this logarithm? Let's say if a power x is equal to n, then we can say that x is equal to, right, this exponent is equal to log n to the base a. So that we are expressing the exponent by using the other terms. So this is how we represent a logarithm, and we have very limited properties in logarithms. Very limited properties. Just learn all these properties and memorize them. Those are enough to solve any problem, any whatsoever the difficulty, right? This is the first property. And what is the second one? To the base b is equal to, when this is division, we will be subtracting log a to the base b minus log c to the base b. What is the third one? Third one is log a power n to the base b. This is equal to n log a to the base b. This n comes front, right? What is fourth one? Fourth one is log 1 to the base b is equal to 0. Now how did we arrive this? See, log 1 to the base b is equal to 0. What is the meaning of this? B power something must be equal to 1. What is this something? This something is 0. B power 0 is equal to 1. So this will be the exponent of this. And in logarithms, please follow this anti-clockwise direction. B power 0, this is equal to 1. So anti-clockwise direction. What is the fifth one? Fifth one is log b to the base b. This is equal to, what is the value? So b power, this is something, b power something must be equal to b. Can I take b square? B square is not equal to b. B power 1 is equal to b. So this is 1. Log b to the base b is equal to 1. Log of something to the base of the same number is equal to 1. Now what is the sixth property? Sixth property is b power log n, b power log n to the base b. This is equal to n. Here n is greater than 0, right? And what is seventh one? Seventh one is the change of base property. Change of base. Change of base in the sense log of a to the base b. How can we write log of a to the base b? We can write it as log of c to the base a by log of c to the base b. we can substitute the value of c. We can substitute any number in the place of c. If we want to change the base of any logarithm, we can change like this: log of a to the base something. You can substitute c, you can substitute any number in this place by log of b to the same number. Alright? And there are certain conditions in logarithms. If I take log b to the base a, right? Log b to the base a. What does this mean? If we take log b to the base a, this base which is a, this one must be greater than 0. And a must be greater than 0, a shouldn't be equal to 1. And when it comes to b, b must be greater than 0. Which means a must be greater than 1, b shouldn't be equal to 0, b must be greater than 0. So these are the rules that you must remember as far as logarithms are concerned, and we shall look into the properties of logarithms when powers are given. When powers are given, let's say log b power p to the base a is equal to p into log b to the base a. P comes this side, right, to the front side. The log b to the base a power cube. So in first case we have power for this value, in the second case we have power to this to the base. So what we can do is, if we have power to this value, then this value that the power directly comes in front. If we have power to the base, then inverse of the power comes here. So 1 by q will be equal to log b to the base a. If the power is here, it will be as it is. If the power is here, that is, if the power is to the base, then the inverse of that will be in front of that log. So log, if power is on both sides, on both the cases, which means log b to the power p to the base a to the power q. Now what will happen? Well, the same rule. Log b, p moves here, and this q will be inverse 1 by q. These three are must. You must remember. Now, what about inverting the signs? Interchanging the signs. If log b to the base a is equal to x, then you can invert the the sign of x as log b is equal to minus x. You can invert this sign plus to minus by inverting this. Now a becomes 1 by a. You can also invert not only the base, you can also invert b. Log of 1 by b to the base a, this will be equal to minus x. This depends on the situation, right? Depends on the problem, depends on the condition. So log of, you can invert both as well. Log of 1 by b to the base 1 by a. Now this minus nullifies and becomes plus. Alright. You are inverting this value and you are getting minus. Again you are inverting the base. So it will be plus. So please remember the previous properties as well as these 6. Alright. These are enough. These are sufficient. More than sufficient. Find the value of what is the first one? First one is log 27 to the base 81. So let us solve this. Log 27 to the base 81. 27 can be written as 3 cube, right? And how can we write 81? 81 can be written as 3 power 5. So in the last slide we learned this property. This power comes as usual 3 log 3 to the base 3, but this one will be inverse. So by 4, 1 by 4. This is the answer. And further we can simplify. Log 3 to the base 3, we learnt log x to the base x is equal to 1. So 3 by 4, this value becomes 1. So answer is 3 by 4. Now find the value of log 9 into 3 power 1 by 2 to the base 1 by 3. So we can equate this to y. Right, we can equate this, and if we observe here, the base is 1 by 3. Now what happens if we invert the base? If we invert the base and if we make it 3, the sign of y changes to minus y. Plus y becomes minus y. Now this is 3, but this is in terms of 9, so we shall make it as 3. So 9 is 3 square into 3 power 1 by 2, this is equal to minus y, right? Now this becomes log of a power m into a power n. So 3 power 2 plus 1 by 2, this will be equal to 5 by 2 to the base 3, this is equal to minus y. Now this 5 by 2 comes to this side, so 5 by 2 log 3 to the base 3, this is equal to minus 1, and this is equal to 1. So 5 by 2 is equal to minus y is equal to minus 5 by 2. So solve this. How can you solve this? Log root 6 to the root 6 and root 6 till infinity to the base 6. So how can we solve this? We can use the concept recursion. So in recursion, what we shall do is, in this case we shall take root 6x as x. Alright, we are comparing this with x. So root 6x is equal to x, because this is in the form log x to the base a. We are comparing this x with root 6x. So let us take this part, ignore the log and base. Let us take this root 6x. Now what is x? X is again root 6, root of 6x. Now what is x? X is again root of 6x. Now what is x? X is again root of 6x. So it will carry till infinity, right? So basically root of 6x is equal to x. If we square on both sides, we will get 6x is equal to x square, where x is equal to 0 or x is equal to 6. Now if we make this 0, what happens? Log 0 to the base 6. As this is not possible, we can make log, so this is not possible, x is equal to 6 we can take. So this is not possible, we can take the other value which is 6. So log 6 to the base 6, this is equal to 1, hence 1 is the answer. It can be 6, it can be any value. If this is in the form, this is the method, or simply you can just calculate, just mark it as 1 as the answer. If the question is in the form and the values, even the values are changing, that's not an issue. Alright, so this is the concept of recursion. So find the value of this. What is the value? So we are asked to find the value. If we observe this 1, 2, 4, 8 and this 1, 0, 2, 4, we can make them as the power of 2, as log 2 power 0 to the base 2 plus log 2 power 1 to the base 2 plus log 2 square to the base 2 plus log 2 cube to the base 2 and so on till log 2 power 10 to the base 2. Alright, and what happens here? This 0 comes here, this 1 comes here, this power comes here, this one comes here. So we can make it as 0 log 2 to the base 2 plus 1 into log 2 to the base 2 plus 2 into log to the 2 to the base 2 plus 3 log 2 to the base 2, so on 10 log 2 to the base 2. Now this value is 1. We already know that these all are 1. So 0 plus 1 plus 2 plus 3 plus till 10. So we are asked to find out the sum. So n into n plus 1 by 2, this is equal to 10 into 11 by 2, this is 55. So 55 is our answer. So this is CAT 2008 question. Even though it is a CAT question, don't feel bad about it. If you are a non-CAT aspirant, if you are a SNAP or if you are an NMAT aspirant, don't feel bad about it. These are standard questions. We are applying each and every concept in different questions, right? We are applying different concepts and we are solving different questions. So this is a good practice for all of you after understanding all the concepts. So don't ignore this. Alright. So the options are 0, 1 by 4, 1 by 2, 1 by 3, B, C and D. This is A. Alright. So what is given here? F of x into f of y is equal to f of xy. And f of 2 is 4. So we are asked to find out the value of f of 1 by 2. So f of 2 can be written as f of 1 into 2. Understood? F of 1 into 2. And what is f of 1? F of 1 can be written as f of 1 into 2 can be written as f of 1 into f of 2. We know f of 2 is 4. So this is equal to 4. How can we write f of 1? F of 1 can be written as f of 2 into 1 by 2, right? And f of 2 into f of 2, this is equal to 4. Now we can modify f of 2 into 1 by 2 as f of 2 into f of 1 by 2. This is f of 2, this is equal to 4. We know the value of f of 2 as 4. So 4 into f of 1 by 2, this is equal to 4. So into 4, this is equal to 4. Now this and this get cancelled, and f of 1 by 2 is equal to 1 by 4. This is our answer. Hope this is clear. Let's move on to the next problem. So this is CAT 2019 slot 1 question. Consider function f satisfying f of x plus y is equal to f of x into f of y, where x and y are positive integers and f of 1 is equal to 2. If f of a plus 1, okay, this is given, this is equal to something, then find the value of a. So this is a theta question. Alright, now this is important. F of x plus y is equal to f of x into f of y. This relation is important. Now here f of 1 is equal to 2. What does this mean? F of 1 is equal to 2, which means what is f of 2? F of 2 is equal to f of 1 plus 1, which is f of 1 into f of 1. So 2 into 2, this is equal to 4. So f of 2 is equal to 4. Alright. What is f of 3? F of 3 is f of 1 plus 2. This is equal to f of 1 into f of 2. So f of 2 is 4. F of 1 is 2. So 2 into 4, this is 8. So f of 3 is 8. So it's a multiplication with 2. F of 1 is 2, that's fine. F of 2 is 4, 2 into 2. F of 2 is 2 into 2. F of 3 is 4 into 2. Then what is f of 4? F of 4 is 8 into 2. F of 5 is 16 into 2, and so on. Now our question is, if f of a plus 1 plus f of a plus 2 and so on till f of a plus n is equal to 16 into 2 power n minus 1. This is important. 16 into 2 power n minus 1. Now 16 arises at which one? F of 3 is 8, f of 4 is 16. So this 16, so f of 4 is equal to f of a plus 1. Because we know that sum of n observations is equal to a into r power n minus 1 by r power r minus 1. Alright. This r power n minus 1 refers to 2 power n minus 1 here. And this here refers to 16, which is the first value. And 16 is the first value. Here 16 refers to 4 power or f of 4. So f of 4 must be equal to f of a plus 1. Then only we can say that f of a plus 1 is 16. 16 is the first value. Let me erase all this. So as we know, f of a plus 1 is, it starts with f of 4, and then f of a plus 2 is f of 5, so on. So what is meant by this? F of 4 is 16, the value of f of 4, the value of f of 5 is 32, and so on till nth. Okay. Now this is equal to a into, a is the first one, so 16 into r power n. So 2 power n minus 1 by r minus 1, so 2 minus 1. So this will be equal to 1, and here if we observe, we know f of a plus 1, right, the first value a plus 1 is equal to 16, which is equal to f of 4. So we can equate a plus 1 as a plus 1 with 4, so a will be equal to 3. 3 is our answer. Simple question. Just observe the Observe this expression, this function, mark it. Not even 20 seconds are required. So let us solve this. Log x minus 1 to the base 4 is equal to log x minus 3 to the base x. Find the number of solutions. Now 4 if log on the other side we have base 2, but here we have 4, so we can convert this. So log x minus 1, we can convert 4 as 2 square. Alright, now this is equal to log x minus 3 to the base 2. Okay, we know when the power is for the base, when it goes this side, it will be inverse. So 1 by 2 log x minus 1 to the base 2, this will be equal to log x minus 3 to the base 2. Now we can transfer this to the power, transfer this as power. So x minus 1 whole power 1 by 2, this is equal to log x minus 3 to the base 2. Alright, so log 2, these are equal. So we can compare these two. So x minus 1 whole to the power 1 by 2, this is equal to x minus 3. Just square the both sides. Just square the both sides. If you square the both sides, we'll get x minus 1 is equal to x minus 3 square. Now x square minus 7x plus 10 is equal to 0. We can split this and we can write it as x into x minus 5 minus 2 into x minus 5. This is equal to 0. X is equal to 2 or x is equal to 5. Now if x is equal to 2, and if we substitute x as 2 here, 2 minus 3, which is negative value, then it will become log of minus 1, 2, which is incorrect. We learned the rule, we learned the property. One of the properties is this one shouldn't be equal to 0. This must be greater than 0. So in this case it is negative, so 2 is not possible, 5 is the answer. Why? Because 5, if we substitute here 5 minus 3, which is 2, it is a positive value. 5 minus 1, which is 4, this is a positive value. So this satisfies. So find the number of solutions, only one solution. And if it is a theta question, if these kind of questions appear in theta, please be very careful. You must fill the box with 1. You must type 1, not 5. Here we are asked to find the number of solutions, not the value of the solution. So please be careful. Don't commit these silly mistakes, because these are very expensive. These mistakes are very expensive. Now let us solve one more question. So 3 by 2 plus log x power 1 by 4 to the base 3 is equal to log 9x to the base x. Find the value of x. So we are asked to find the value of x. So 3 by 2 plus 1 by 4 comes here. As we know, 1 by 4 into log. See, please remember and learn, memorize all the properties first, because they all are handy. All will be handy. We don't know where to apply which property unless we know the property, right? Be very clear with all the properties of logarithms, surds, indices, and everything. Okay, so log 1 by 4 log x to the base 3, this is equal to log 9. We can split 9x as log 9x plus log x. So log 9 to the base x plus log x to the base x. So 3 by 2 plus, so we have one property. We have one more property. Log of, let's say log of 9x in this case, right? If we say log of 9 to the base x, we can interchange this by inversing this. So 1 by log x to the base 9, we can make it like this. Log 9 to the base x can be written as log x to the base 9 inverse this. Alright, so in the same way we can write this. We can make log x to the base 3 as 1 by 4 into log 3 to the base x. This will be equal to log, this 9 is 3 square, 9 can be written as 3 square to the base x plus log x to the base x, which is equal to 1. We will solve this. So 2 can be here, alright, 2 is here, and log x to the base x, this will be equal to 1. So this will be equal to 1. Now if we observe log x, log 3 to the base x and log 3 to the base x, let us assume log 3 to the base x as a. What happens if we assume like this? 3 by 2 plus 1 by 4a is equal to 2a plus 1. So this makes our calculation simpler. Now if we take LCM and all this, we will get 12a plus 2 is equal to 16a square plus 8a, and this will be equal to 16a square minus 8a plus 4a minus 2 is equal to 0. Alright. Now 8a into 2a minus 1 plus 2 into 2a minus 1 is equal to 0. Let me erase this part. Okay. Now 8a plus 2 into 2a minus 1 is equal to 0. A can be minus 1 by 4 or a can also be 1 by 2. And what do we have? We assumed a as log 3 to the base x. So this can be equal to minus 1 by 4 or this can also be equal to 1 by 2. Let us use this again. Let us use this formula again. The property. So 1 by, we can make log 3 to the base x as log x to the base 3 by just inverting this. So 1 by log x to the base 3, this is equal to 1 by 4. In the second case, we have 1 by log x to the base 3 as 1 by 2. Let me erase this. So in this case, what will happen? Log x to the base 3 is equal to minus 4 and x will be equal to 3 power minus 4. This is equal to 1 by 81, right? 1 by 81. This is case 1. And in case 2, we have log x to the base 3 is equal to 2 and x is equal to 3 square. This is equal to 9. So both these satisfy this equation. Hence x is equal to 1 by 81 and x is also equal to 9. Hope this is clear. So how many values of x satisfy the equation? Alright. So log, here we have 4. Base is 4. So let us change this 16 as 4. 16 can be written as 4 square. So 2x minus 5, log 2x minus 5 to the base 4 square. This is equal to log x minus 4 to the base 4. Now when 2 is the power of the base, when 2 comes to this side before log, then it will become 1 by 2 log 2x minus 5 to the base 4. This is equal to log x minus 4 to the base 4. Now 1 by 2 we can make it power of this. So 1 log 2x minus 5 whole to the power 1 by 2 to the base 4. This is equal to log x minus 4 to the base 4. So log 4 and log 4, this is same. So we can equate these two. So 2x minus 5, 1 by 2. Instead of 1 by 2, we can take a square root. So this is equal to x minus 4. If we square on both sides, or you can directly bring this 1 by 2 to the other side, you can square it. So 2x minus 5, this is equal to x minus 4 whole square. So if we just simplify this, we'll get x square minus 10x plus 21 is equal to 0. As this is a quadratic equation, just find the roots. X minus 3 into, just split this, 3, 7, 21, okay. X minus 7, this is equal to 0. X is equal to 3 or x is equal to 7. 3, check whether 3 is not 3 is possible or not. 3 is not possible because if we substitute 3 here, it is a negative value, right? So 3 is not possible, 7 is possible. So the answer is 1. Only one value of x satisfy the given equation. So let us solve this. This may seem complicated, but not at all. So if we look at this RHS, this is equal to 14, right? I mean log 16 to the base 4. See, log to the base 2 into log 16 to the base 4. How can we write this 16? 16 can be written as 4 square, right? So 16 can be written as 4 square. We can just bring this to this side, so that log 2 to the base 2 and log 4 to the base 4. Now log of something to the base of that is equal to 1, we know. So this is equal to 1 into this is equal to 1. So the whole entire thing is equal to 1. Alright. So we know this is equal to 1 now. Alright. So log into x cube minus 27x square plus 243x to the base 9. This is equal to 1. Just observe, if we take this one as a unit, just recall the anticlockwise direction of logs. Log of something to the base 3 is equal to 1. Is it so? See, we are considering this whole part as a unit, right? As we are considering the whole part as a unit, this unit, log of this unit to the base 3, log of this unit to the base 3 is equal to 1. So what is the meaning of this? Please recall the anticlockwise direction of logs. 3 power 1 is equal to this. So 3 power 1 is equal to this box. What is 3 power 1? 3 power 1 of something is equal to 3 power 1 is equal to 3. Hence, this part, the interior part, which is log into x cube minus 2x to 27x square plus 243x to the base 9 is equal to 3. Now we will do one thing. We will take this part as 1 unit. Now this is like log something to the base 9 is equal to 3. And again recall the anticlockwise direction. 9 cube is equal to something. So 9 cube is equal to something. What is that? What is 9 cube? 9 cube is 729, right? So this one is equal to 729. This part is equal to 729. So x cube minus 27x square plus 243x is equal to 729. Which is x cube minus 27x square plus 243x is x minus 9 whole cube. This is equal to 0. Let me take this. This is equal to 0. So x minus 9 is equal to 0 and x is equal to 9. So how many unique real values are there? Only 1. So 1 is our answer. See, very simple one. See, here log of something. This one is given to the base. This is base 9. This is base 3 is equal to something. So first we calculated the value of this, the RHS part. RHS we calculated and the value is 1. Now we have taken this one as 1 unit and we just applied the anticlockwise property of log. So 3 to the power 1, 3 power 1 of something. So 3 power 1 of something is what? 3 power 1 is 3. That's it. So this integral part is 3. So this part is 3. Again we applied. We have taken this one as a unit and log of 9 of something is equal to 3. So 9 power 3 is equal to something. What is 9 power 3? 729. So this part is equal to 729. When we bring this to this side, it will be minus 729, which is equal to x minus 9 whole cube, and we got x as 9. So let us solve this. Suppose log x to the base 3 is equal to log y to the base 12 is equal to a, where x, y are positive numbers. If z is the geometric mean of x and y, find the value of log z to the base 6. So z is the geometric mean. Alright. Since log x to the base 3 is equal to a, log y to the base 12 is also equal to a. So here x is equal to 3 power a and here y is equal to see this anti-clockwise direction. 12 power a is equal to y. So y is equal to 12 power a. As this is GM, geometric mean, so geometric mean of a and b, this will be in the form of 2 into a into b, 2 into root of ab. So g will be equal to 2 into what is a here, 3 power a, and what is b, 12 power a. So x and y, so 12 power a, this is equal to 2 into square root of 3a into this 12 power a can be written as 3 power a into 4 power a. So 3 power a into 3 power a into 4 power a, this will be equal to 2 into square root of 3 power 2a into 2 power 2a. Just simple calculation. So g will be equal to 3 power a into 2 power a, and this is equal to 6 power a. Alright. So what is g? G is equal to 6 power a. Now we are asked to find out the value of log g to the base 6. Alright. We know the value of g. Just substitute here log 6 to the power a to the base 6. What is this? This is equal to, let us bring a to this side. So a log 6 to the base 6, this is equal to 1. So a into 1, this is equal to a. So a is our answer. Alright, so let us solve this. The value of log root 5 to the base 0.008 plus log 81 to the base root 3 minus 7. So let us calculate the value. This appeared in slot 1 of CAT 2017. So how can we calculate, how can we make root 5? We can make root 5 as 5 to the power 1 by 2. Alright, 5 to the power 1 by 2. And what about, so 0.008? This is 0.008 is 8 by 1000. So 8 by 1000 is 1 by 125. 1 by 125. And 1 by 125 is 125 power minus 1. And this is 5 power minus 3. So we can also convert this base in terms of 5. So 5 power minus 3 is the base now, and plus log 81 and 3. Base is in terms of 3 and 80. Let us convert 81 in also in terms of 3. So 3 power 4 and base 3 root 3 can be written as 3 power 1 by 2 minus 7. Let us take this all these powers to the front side. This becomes as usual, so 1 by 2 by this will be inverse, minus 3 becomes 1 by 3. So this will be minus 3 by minus 3 of log 5 to the base 5 plus 4 becomes 4 and 1 by 2 becomes by 1 by 2, and this is log 3 to the base 3 minus 7. So this is equal to 1 and this is equal to 1. So minus 1 by 6 into 1 plus this will be equal to 8 into 1 minus 7, and this is equal to 5 by 6. 5 by 6 is our answer. So if log 2 power a into 3 power b into 5 power c is the arithmetic mean of log 2 square into 3 cube into 5 comma log 2 power 6 into, and so okay, 3 are given. So this one is the arithmetic mean of these 3. Alright, and find the value of a. What do we mean by arithmetic mean? Arithmetic mean can be expressed as a plus b plus c by 3. Alright, a plus b plus c by 3. So if we observe here we have 2 square. The base is 2. Here the base is 2. Here the base is 2. Same goes with 3. Here the base is 3. 3 and 3. And the base is 5. 5 power 7. 5 power 4. So all the bases, all 3 bases are there. Hence we will write log 2 power some base some exponent a into 3 power, as all these are multiplication, so into 3 power b into 5 power c. See, this is the arithmetic mean of these 3. So this one is the arithmetic mean of, what is a? A is log of, I am not interested in writing all this. So log of a plus log of b plus log of c by 3. This is the general form. Now do we need to calculate all the values, the value of a, b and c? No, we need to calculate only the value of a. So what we shall do is bring this 3 to the other side. So 3 log 2 power a into 3 power b into 5 power c. This is equal to log, just calculate the values of only a. 2 square into 2 power 6 into 2 power 1. So 2 square into 2 power 6 into 2 power 1, this is equal to 2 power 2 plus 6 plus 1, this is equal to 2 power 9. So log of 2 power 9, and ignore all the values, and the denominator we already we already sent this to the other side. Alright, you can also ignore these two values. We are just interested in calculating the value of a. Now 3 log 2 power a, how can we write this? Log, we can bring this to this side, make it a power. So log 2 raised to the power 3a, this is equal to log 2 to the power 9. Now this log and log are equal, log 2 are equal, so just equate the exponents. So 3a will be equal to 9, is equal to 3, hence the answer is 3. Simple thing, where we didn't calculate the values of b and c, since we are just asked to find out the value of a. That's why we equated the value of a of the LHS with the value of a with the RHS. The moment you see AM, arithmetic mean or geometric mean, the expression or harmonic mean, the expression must come there, right? The value must come like this. AM is equal to a plus b plus c by 3. Let us solve this. If log of something is equal to 3 and log of something is equal to 3, then calculate the value of a plus b. Okay. Here the base is 2 and here the base is 5. Alright. So let us take the first one. Log of 5 plus log 3 log a to the base 3 to the base 2, this is equal to 3. Now we can write this as 5 plus log a to the base 3, this is equal to 3 square, and log a to the base 3 is equal to 3, and a is equal to 27. Let's move on to the other part. Log into 4a plus 12 plus log b to the base 2 whole to the base 5 is equal to 3. This can be written as 4a plus 12 plus log b to the base 2, this is equal to 5 cube. Now 4 into 27, as a is equal to 27, just substitute here. 4 into 27 plus 12 plus log b to the base 2 is equal to 5 cube. Now this is equal to log b to the base 2. Just simplify this. 125 minus 12 minus 80 minus 28, and this will be equal to 5. So log b to the base 2 is equal to 5. B is equal to 2 power 5, this is equal to 32. A is equal to 27, B is equal to 32. What is A plus B? A plus B is 59. 59 is the answer. Alright, so if x is a positive quantity such that 2 power x is equal to 3 power log 2 to the base 5, then which are the following 4 values, 4 options will satisfy? Alright, so what can we do here is, if we apply log on both sides, let's say log 2 power x to base 3. Now why are we taking base 3 here? This depends on situation. We can take any base, but here why we are assuming as base 3 is because we have 3 here, so that we can cancel that and we can equate that, it can be equal to 1. As we proceed, you will be clear. So this will be equal to log 3 to the power log 2 to the base 5 to the base 3. Now this is a power, we can bring this to this side. So log 2 power x to the base 3, this is equal to log 2 to the base 5 and log 3 to the base 3. Now this is equal to 1, right? and this is a power, we can bring this to this side and this will become x, and log 3 to the base 3 is equal to 1. So x is equal to log 2 to the base 5 by log 2 to the base 3. Now just see here, just observe here, we have base 5 and here we have base 3 in the denominator. So base, how can we make the bases same? And here we have 2 and 2. So we have to just invert this, right? And we have this property, when we want to invert the base, we have to take the inverse of it. So 1 by log 5 to the base 2 by 1 by log 3 to the base 2. We discussed this property in previous slides. So this will be equal to log 3 to the base 2 by log 5 to the base 2. Now this will be equal to log 3 to the base 5. This is the answer. But in options, can you find this answer? No, we cannot find this answer. So if we observe option 3, which is 1 plus log 3 by 5 to the base 5, how can we rewrite this? We can rewrite this as 1 plus log 3 to the base 5 minus log 5 to the base 5, right? So log 5 to the base 5, this is equal to 1. So this will be equal to log 3 to the base 5. 1 minus 1 plus 1 get cancelled and we are left with this and this is equal. So option 3 is our answer. So what is the next one? If log 81 to the base 12 is equal to p, then 3 into 4 minus p by 4 plus p. So we are asked to find out the value of this. So what is p? P is log 81 to the base 12. Let us substitute here. Then it will become 3 into 4 minus log 81 to the base 12 by 4 plus log 81 to the base 12. Now this will be equal to 3 into, how can we rewrite 4 so that the base will be equal? So if we log, see here we have log 12. Can we write it like this? Log 12 to the base 12 power 4 minus log 81 to the base 12. Can we write it like this? This one is equal to 1 and this will be equal to 4, and minus log 81 to the base 12 remains the same. Why we are writing like this is to make the bases equal, right? Here we have 12 as base and here also we have 12 as base. So let us change the denominator as well, just a manipulation. So log 12 power 4 to the base 12 minus log 81 to the base 12. Now this will be 3 into log, this is a power m minus, see the property log of a minus log of b, log of a by b. So log of 12 power 4 by 81 can be written as 3 power 4. What is the denominator? Log of, this is base 12 and this is base 12. So log of, this is log of a minus log of b, log of a into b. So 12 power 4 into 3 power 4. So this is equal to 3 into, let us bring this to the other side, 3 into 4 log 4 to the base 12 by 4 log 36 power 4 to the base 12. So this 4 and this 4 get cancelled, this 4 and this 4 get cancelled. Now we are left with 3 into log 4 to the base 12 by log 36 to the base 12. So this will be equal to 3 by 2. So this is 3 log 4 to the base 12 by log 36 to the base 12. Now what is this? We know the base change property, right? Which is log a to the base b can be written as log a to the base m by log b to the base m. M can be anything. You can write it anything. So here it is, we can write this as 3 by 2 to log 4 to the base 36, and this will be 3 by 2 log 2 squared to the base 6 and log to the base 6, because this 3 goes to the other side and it will become square. So this will be equal to log 8 to the base 6. 2 cube, so what is the final value? Log 8 to the base 6 is the value of this one. Let x and y be the positive real numbers such that log x plus y to the base x plus log x minus y to the base 5. Okay, log x plus y to the base 5 plus log x minus y to the base 5 is equal to 3, and this one is, and log y to the base 2 minus log x to the base 2 is equal to 1 minus log 3 to the base 2. Then x into y equals how much? So let us take the first one, log x plus y plus log x minus y is equal to 3. Now the moment you see log of something plus log of something is equal to 3, it is in the form log a plus log b, which is log a into b, right? Log a into b. So log x plus y into x minus y to the base 5 is equal to 3. X plus y into x minus y, this is equal to x square minus y square to the base 5 is equal to 3. Remember the anticlockwise direction, 5 cube is equal to this. So x square minus y square is equal to 5 cube. X square minus y square is equal to 5 cube. This is our equation 1. Now let us consider the second one. So x square minus y square is equal to 5 cube. This is our equation 1. If we consider second one, which is log y to the base 2 minus log x to the base 2 is equal to 1 minus log 3 to the base 2. It is log a minus log b. What is log a minus log b? Log a by b. Alright. So log y by x to the base 2, this is equal to 1 minus log 3 to the base 2. How can we write 1 in terms of log to the base 2? Log, we can write it as log 2 to the base 2 minus log 3 to the base 2. Right, 1 can be written as log 2 to the base 2. Now we can take it as log 2 by 3 to the base 2. So log 2 and log 2, log to the base 2 and log to the base 2, these two are equal. Hence we can equate y by x. Y by x is equal to 2 by 3. So y by x is equal to 2 by 3. And we also know the equation. This is the second one. This is the first one. So let us take x as 3m whole square minus, and substitute in the first equation y as 2m whole square. This is equal to 5 cube. So 9m square minus 4m square is equal to 125. 5m square is equal to 25. Right, 125. M is equal to 5. As m is equal to 5, x is equal to 3m. This is equal to 3 into 5. This is 15. X is equal to 15 and y is equal to 2m. 2m is equal to 10. So x is equal to 15, y is equal to 10. We want x into y. So 10 into 15, this is equal to 150. Good question. So we have discussed entire concept of surds, indices, logarithms. We solved lot of problems, right? Different questions. We applied almost each and every property of each and every topic. So keep revising all these concepts, all the properties. If you haven't subscribed our YouTube channel, do subscribe it. You can also join our Telegram group. And we shared the link, joining link, in the description. Thank you very much and all the very best.